Oh, full house. Hi, well, my name is Mario. Charles, thank you for all the nice words about me. So here, the talk will be about this nice history between back then a small startup uh, and a top educational institution in Japan. That story started 8 years ago, and I'd like to start it uh, in a very academic fashion, a bullet list. So first, we're going to go for the context. Uh, what, uh, why, how, who, and how did it happen, who was involved, this sort of thing. Then I'll go to what we have been doing for all these 8 years, and in terms of research, but also in terms of classes and other activities. Then what happened more recently with that? In here, we start going to narrow down into the research. And finally, and perhaps I guess some of you will be more interested, what we have for the future, what we're looking at. So it's very simple presentation. It will be context, past, now, future. That's it. Very straightforward. Going. All right. So context. Back then, there was this startup interested in building this distributed research environment. So a network of centers for research that could talk to each other and preferably close to some already established places for research excellence centers. The thing is that in theory that's very nice, but reality is that distances, time zones, will cause people to have meetings until midnight, 1, very early in the morning, and I'm talking from experience, I should add. And so what we usually approach the problem was that we're going to do a lot of work on our own, in our space, and eventually get together to share and to speed up some developments. So here in the picture, you see probably, I'm pretty sure, the very first time that all back then IOHK, but now IO, got together for the first time. All IO is in that picture at that time. That's me. Should be Mario, but sort of like it, Mario. Looks like Lion O from Thundercats. So Mario is fine. So that was in 2016. Okay, so those opportunities to get together, well, we have to do it because it could speed up. And I think what I want you to notice is the head count got larger and larger. And I think this is the last time that we put everybody in the same space at once. And you can see that the head count is pretty high now in this picture. And that was in 2019, the years over there in the picture. And I can see your faces, and I kind of guess the question, and the answer is yes. Mario Yo is there. I'm there. All right. So we had this distributed research environment. If you go to the IO webpage, you'll see us just next to Stanford, University of Edinburgh, Wyoming, Carnegie Mellon. It's very easy to spot. Just look for the kanji in the website. You'll find us. Oops. All right. So how did it start? That was in 2016. And we start sneaking in some seminars here in the Institute, thanks to Professor Keisuke Tanaka, which is in here in the audience. Thank you, Professor. He allowed us to join the seminars, and you can see him in the picture taking picture of our development. Thank you very much, Professor, for the support so far. And you can see a very slim version of myself there in black t-shirt. Then we straightened our relationship, and when we created this collaborative research chair, which worked between 2017 and 2020. So if you look for it on the internet, this picture will show up all over. This is the signing ceremony. Again, you can see ourselves there. Charles was there too. So here's the timeline. So we started mid-2016. We had the orange part for the research chair, and now we have our current form of our group from 2021 until now. Here is the current form. This is the team. Those handsome gentlemen are our group here. These are the pretty faces behind the pretty magic. So there you have it. Context and the people. So on side on IO, there's me, Mario Larangeira, Maxine Johanko, which we call Max. We have Professor Keisuke Tanaka, always give the support. And from his group, Jiangyu Su, which we call Su. They will come up later in the presentation. So now you know the history, you know the people, and sort of why. What happened in the past? We have this cryptography blockchain course, which it happens since 2018, usually in the first quarter of the year, and usually we have 14 lectures, 100 minutes each, so twice a week, and we teach basics of blockchain, but we also put some how can I say, salt of cryptography. So we put some emphasis on cryptography, sometimes should say a heavy hand on cryptography, because we try to put a lot of formalization into the classes. And in the picture, you can see myself. You see Max also teaching layer 2 protocols, payment channels, and Sue teaching credentials. And very often, we get nice messages like this one from one student, which makes it all worth it. This year, in particular, we got a very special guest, which was Takeshi Chino, the general manager of Binance Japan. He offered to give a special class for us, which was very nice, because he was able to cover part of the course that we don't cover very closely in our course, which was Web3, gamification, and NFT. And I remember very vividly that there's a lot of questions in the end, so lots of interest from the students. We also held workshops, single days workshop, in order to spread the word, let's say. And what we're doing, this was in 2018. Charles was here too. Professor Tanaka is in the picture, and some former members of our group. We also received this delegation of French researchers, and that's why, I don't know if you all noticed, in that picture of our current group, there was a French flag in the back that was in the French embassy. We got a very nice reception, and we also hosted a visit of this delegation here at the campus for a single day workshop. Okay. We keep some videos of our activities. So we have this, for example, this one is about the delegation system on the left, right, yeah, left side for you. And I also took the liberty to take one from the whiteboard series from the IO channel, because that particular video was shot in my office So you can have a glimpse of it in the background, how it looks like. And well, this is sort of our whiteboard series here. Visitors. We have few visitors during these years. This is Dimitris Karakostas. He is a researcher of the University of Edinburgh, the partner lab in Scotland, and he visited us 2 years ago to tell us about the EDI, the Edinburgh Decentralization Index, measure of how decentralized the system is. It's an ongoing research activity. He's involved in this, and he's also a close collaborator in some papers. In fact, me and Dimitris, we contributed to this book, one chapter about security for proof of stake systems, which outline attacks and also explain our approach in terms of delegation. Another notable visitor was Dave Chow. Dave Chow is a big name in the history of cryptography. He developed crucial technologies for privacy, for example, blind signatures, anonymous credentials, and he's also very active in the cryptographic society. He helped to create the Association of International Cryptographers, for example. And in addition to that traditional picture in front of the gate with the name of the institute, we took this very nice picture, which I could help but put it here because me and the other Mario, the one in the picture in the middle, we joke that this photo looks like the cover or some rock band album. And so it was nice for us. So I could help to put it. All right, more cryptographers coming. So we have Professor Bernardo David, which is a former member of our group, Professor Karsten Baum, and Claudio Orlandi. They visit us here. They are all based in Denmark. Raphael Dosley, which is also a member of our team, who was previously based in Denmark, but now in Australia, in Monash University, and probably will come this year too. And Steven Zeboski, who gave us a crash course on payment channels. So here you can see the pictures. The one in the top right, we are working in a recent paper, which I'm going to talk about later, called MUSEN. And have to say that Denmark has too many cryptographers. So from this list, you can see 4 have connections in Denmark. Okay, so what it all has to do with Cardano. There's a nice blog post on the IO website that highlights the crucial technology that it is in the system. And I highlight in this picture those that we directly contributed. And those are the initial versions of the Ouroboros protocol. Here on the left, in the Byron era, you could see that I think the one running right now was also developed here. And on the Shelley area, we also contributed to the delegation scheme. So how we delegate within Cardano, how the stake pools are organized, pledge, their certificates, and it's all there. The system of addresses, for example, it is from this paper. Okay, so context past. What about now? What we have now, or more recently, let's say. I divided sort of, not very formally, in like this 4 fronts. But I have some disclaimers. First, I'll just announce, so we worked a little bit of key derivation in this thing called sleeve, which I'm going to explain, wallet and cryptographic tools, layer 2, which is a big thing around here, and proof of useful work. So the disclaimer is, first one, is that I'm not going to talk much about the proof of useful work because that's going to be Sue part presentation. And I'll talk a little bit about layer 2, but our current developments, I think Max will give a nice talk about it. Another disclaimer is that I'm leaving a lot out of the research that we did because that's not directly concerned this talk about the story. So here is one, for example, but in fact, it's just an excuse to show that we have a nice IEEE best paper award. I had to do it because it was very recent and I'm still very happy. So we use the structure that UTXO has in order to get some speed up to the settlement of the BFT protocol. That was very recent, last year, December, for Christmas. All right, having said that, I will be a little bit more technical about the work that we do. So key derivation. So we work in this thing that we call sleeve. We have 3 papers on that. The idea here is that in addition to the ECDSA keys that we know and love and use for signing transactions, we created this backup key that we embedded in the secret key. So this is a special key that we don't use regularly for transactions. For example, we only use if something goes bad. So in the original motivation is that if your key is leaked, then you have to prove that you're a real owner of the key. There's no use if the key is out, everybody knows, to generate a zero knowledge proof, for example, because everybody knows the key. So you need some structure that only you know. That's more or less the idea that we put into the backup key. So you keep in a separate space. If something goes wrong, you go there and prove yourself. But there's more on that, because that particular idea relates to post-quantum readiness and proof of complete knowledge and unencumbered knowledge. What does it mean? Is that you show that you are the real one who actually created the key. So that's the complete knowledge that this is it is referring to. One more thing is post-quantum readiness, because we didn't put any key there. We put a key called from a signature scheme called Watts plus, and we didn't put only the key. We put the entire signature scheme there. So, and Watts plus is a hash-based signature, quantum resistant. That's why. And just the final words on that is that this is a collaboration of the Rock Band people. Okay, so wallets. We have this work from 2021, which is a collaboration with Dimitris Karakostas, which I mentioned earlier, and Aguilos Calles. Here, the idea of this wallet is that we can put some small number of people and combine the wallets as like they are working together as one. This is a little bit old, but it let us thinking about the properties of the keys and signatures, actually, and in comparison to the keys of a VRF, verifiable random function, which is a key component of POS systems, proof of stake systems, because the randoms generated through this function is actually used to prove that you are the slot leader, for example, and other proofs. And signature keys have this property well established with for security, which the keys evolves, but not much in VRFs. So we started looking into that to add this property to VRF. It's important because when you evolve in the future, if you are a verifier and your key leaks, the hacker, malicious, could take this key and try to rewrite the history, and that's bad. But if you evolve it, you cannot reuse it from the beginning of the history. That's why that's the forward security idea. So we propose this construction we call MUSEN, and have a very new paper on that. That's why it is in the present part of the talk. And in fact, it's so new that's not even presented in the conference. It will be presented actually tomorrow in the SN conference in Italy. This conference is fairly competitive, happens only every 2 years, and it's going to happen in this boring place. And I cannot emphasize more. I decided to stay here to present to you instead of going there to present, because Amalfi Coast is really overrated. Nobody wants to go there. All right, so this is MUSEN. About layer 2, what we have here, we have this, I find, very neat protocol. And this is actually presented. This was presented in Africa Crypt last year. And the idea here is that there's all this talk about finality to make the ledger fast so it can settle transactions quick. we looked a little bit different to this problem, and instead we worked on a very flexible definition for finality, which is when you buy something to some store, the finality only for that particular store, for the merchant, we say. And how it works, it's a hybrid approach. So the customer will pay through the ledger, but then we introduce a third player, which will guarantee the payment by paying in advance through a payment channel, taking a fee. So if you think about it, that already happens in credit cards. When you present your credit card, you're not paying, money are not flowing. You're just somebody guaranteeing the payment. So that's what we sort of introduced. It's not so simple, but it's something like that. So that's what we call the Maraved protocol. That was presented last year in Africa Crypt. And then we have the Hydra front. We have some work on Hydra. I guess you all know that's the Basho era in Cardano. It deals with scalability. We want to increase the number of transactions. And I have to say, before going to the works that we have in the bullet over there, I have to say that I was really surprised because you all think layer 2, very complex applications and multi-party computation. They're all you can do. But recently I learned that you can play Doom in Hydra, and that was really, really, I mean, my childhood heart beat a little bit harder on that. That was a low blow, Charles. Yeah, you lured us to work on Hydra. So Interhead, that's what we call it, because you all know that Hydra, we have this multi-party channel, which we call the head, that does computation among themselves. And we were wondering, how can we go from one head, two independent heads, and merge them safely and securely? So basically what we want to do is all the heads, for example, the red ones are the heads, they work independently. We want a way to do this, put in very simple words. And so we had two works on that with that idea. We tried, our first approach was published in Marble 22, which we call the interhead Hydra. Two heads are better than one. It was our first approach. It was kind of we couldn't sort. Well, we could sort. We have it, but we had this idea that we could do better. And then Max had a nice idea of how to generalize it and do it more in a cleaner way. And we presented this paper in the bottom in the FC conference, a very competitive venue, and probably now the most famous one for blockchain works. But we have something new, and this is what we call the audit Hydra. If you think about it, the off-chain protocols, the layer 2, they do not interact much with the ledger. So a lot of things are opaque. So if some regulator comes and they want to know, of course, the regulator will want to know everything. So we are trying to come up with a protocol that's we go the middle ground. So a regulator can test some regulation. So AML, KYC. So we can support, nurture adoption of a Hydra-like protocol. And so we came up with this protocol that the nodes keep statistics and can answer queries from a regulator. So we have a work for that too. It's, again, very new. It's not even presented, and it will not be presented until this month. So it's going to be presented in the CANS conference by the end of this month in Cambridge University. So we have to go to England to present it. Needless to say, all those papers, as you can see in the bottle, they are available on the IOG library website and also in the ePrint archive. So everything is open. All right. We arrived in the future. So from now, I will invite Maxine Johanko to come and give us a glimpse of what we have ahead, and then later Stu will come.